Hi everyone. In my last video, I spoke about packet filtering firewalls and how they act as the first line of defense by checking basic packet information. But firewalls have evolved and now it's time to explore more advanced types that offer deeper inspection and smarter control over what gets in and out. In this video, we are going to discuss three important types of firewalls: stateful firewalls, application level gateways, and circuit level gateways. Don't worry if you feel too technical about it. I'll try to keep it simple. And we are also going to see how each one helps protect our networks in different ways. So let's get going. The first category of firewalls that we are going to discuss in this video are stateful inspection firewalls. Stateful inspection firewalls are advanced security systems that monitor and filter network-based traffic on the state and context of active connections. The main difference between these and the earlier discussed packet filtering firewalls is that a packet filtering firewall only checks the contents that are present in a packet but do not take any connection data at the upper layers. So, unlike basic packet filtering firewalls, which check only individual packets, the stateful firewalls track the entire communication session, making them more secure and efficient. What it means is, see, if you compare it with the traditional packet filtering firewall, which we observed in the last video, I also have explained the set of rules that are usually given for a firewall to decide whether to allow a packet or deny a packet, isn't it? So a traditional packet filtering firewall makes independent filtering decisions for each packet without considering its higher layer context. So it does not take what connection it belongs to or any other stuff. It only looks at the data that is present in the packets. A simple packet filtering firewall must allow incoming connections on all higher numbered ports. So anything between 1024 to 65,535 or any connections or any packets which are traveling to these particular ports are allowed to enable legitimate TCP based traffic. This broad allowance creates a security vulnerability as unauthorized users can exploit these open ports. Now, how do we overcome this? What does a stateful inspection firewall does to overcome this limitation that is present in a packet filtering firewall? A stateful inspection firewall improves security by tracking the active TCP connections. If you remember, TCP is connection oriented and a connection is established before any communication takes place, isn't it? So an active TCP connection and allowing incoming traffic only if it corresponds to an established connection. So only if there is a connection that has been established, this particular firewall will keep track of that connection and will allow traffic or packets that belong to such established connections only. It maintains a connection state table which stores details of outbound TCP connections, such as, if you see here, which are source IP address and port address, destination IP address and port address, and TCP connection state. Let me show you a quick example of how these things are put together within the perspective of a stateful inspection firewall. Check out this example. A stateful firewall maintains what we call as the state table to track the active connections. These are the information or attributes which are present in a state table. The first one is the source IP address and the source port address. Now, these two correspond to the internal system that initiated the connection. And the next two are the destination IP address and the destination port address. These are the two attributes which indicate the external server that the packet is communicating with. The next one is the protocol. Which upper layer protocol, whether it is TCP or UDP or any other protocol that is being used. The next one is the current state of what type of state it is in. You can see there are three things that are listed over here. The first one is established. The second one is sent, which is nothing but the synchronization flag that has been sent. And the third one is an active state. Let me explain to you what these three states are. Now, if the state is as established, which means that there is an active two-way communication is going on using TCP protocol. Similarly, if the state is synchronous sent, then this means that the initial connection request has been sent and the packets are waiting for a response. Last one is the active state, which tells you that the protocol that is being used is UDP, which is connectionless, and such a state is used for UDP connections indicating recent activity, because UDP is a connectionless protocol. And the last attribute is nothing but a timestamp, which is nothing which tells you the last recorded activity for the session. So these are the different attributes which make a policy for stateful firewall, and this is what we call as a state table through which the decisions are made by the stateful firewall. Now, not just these things, beyond tracking the TCP session states, some of the stateful firewalls can also monitor the TCP sequence numbers, which are used to prevent attacks like session hijacking. And also, they are able to analyze limited application layer data, not very much, but limited application layer data for well-known protocols such as FTP, SIP, and the instant messaging to track related connections. So, of course, you might have understood by now that this is a significant development on what packet filtering firewall does, but there are several limitations which are also present for the stateful firewalls. The first one is these firewalls are vulnerable to certain application layer attacks. They do not deeply inspect the application layer data, making them ineffective against malware, SQL injection, cross-site scripting, and other application layer attacks. The second limitation is these are susceptible to spoofing and also manipulation attacks. So we studied about what do you mean by session hijacking in my earlier video. And if an attacker is good enough to manipulate the sequence numbers and thereby can take hold of an entire session, he will be able to manipulate the entire session and masquerade as one of the communicating entities. This is also susceptible to such attacks. Third one, most important one for me, is these particular stateful firewalls are resource intensive because they store the session information for every connection, requiring memory and also processing power. In high traffic environments, large connection tables can cause performance bottlenecks. And also, these are not effective against encrypted threats. If the attackers do have the capability of tunneling malware inside the encrypted packets, these particular firewalls will not be able to safeguard against such attacks. Let's move on to the next one, which does actually do some kind of deep packet inspection called as application level gateway, or in short ALG. An application level gateway, ALG, also known as an application proxy, functions as an intermediary for application layer traffic. Instead of allowing direct connections between clients and servers, the gateway relays application data while enforcing the security policies. Unlike packet filtering or stateful firewalls, which only work at layers either 3 or 4, which are your network layer and transport layer, the application level gateway inspects and filters traffic based on application specific protocols like HTTP, FTP, and SIP. Now, how does it work? The first thing is the user initiates a connection to the gateway using an applications such as Telnet, FTP, or HTTP. This connection will be received by the gateway. Then the gateway requests authentication, the username, password, and any other mechanisms that are required to authenticate. Upon successful authentication, the gateway establishes a connection with the destination server. The gateway now acts as a middleman, forwarding only the permitted application data between the client and server. Now, what do you mean by permitted application data? That means if I don't want to accept one particular application, maybe FTP is not allowed, the gateway will automatically block all incoming FTP requests. If the proxy does not support a specific application, the traffic is blocked. Now, additionally, the gateway can be configured to allow only certain features of an application, restricting risky operations while blocking unauthorized activities. That means I still can have control whereby I can allow a particular application, but restrict the usage of application also. What kind of, in what way the application can be used. So this is how an application level gateway works. What are the advantages of an ALG? It provides stronger security because it analyzes and filters application layer data. They offer better protection against malware, exploits, and even unauthorized commands. The second one is it does provide you granular control. The administrators can permit or deny specific features within an application. That means, as I told you, allowing FTP file downloads but blocking uploads. I can do it. The third one is comprehensive logging. Since all the traffic passes through the gateway, all activity can be monitored, logged, and audited for security analysis. Of course, there are limitations as well. Let us talk about the disadvantages or limitations of application level gateways. Now, the first thing should come to your mind is if you are talking about a deep packet inspection, then obviously there is bit more there is a processing overhead that is involved. So increased processing overhead. Each connection involves deep packet inspection and a traffic relay, which requires more computational resources, potentially slowing down network performance. If you want a high-speed network performance, this might not be the right choice. And the remaining two limitations are it does provide a limited application support only. Only applications with proxy support can pass through the gateway. Unsupported services are automatically blocked unless new proxy rules are implemented. The final thing is these ALGs are complex to implement. The managing application specific rules and authentication settings can be time consuming compared to simpler firewall methods like your packet filters or even stateful inspection firewalls. We do have another one, the third variant, something called as a circuit level gateway or a CLG. This is also called a circuit proxy, which is a type of firewall that manages TCP and UDP connections without inspecting the actual data being transmitted. This is a stark contrast to your application level gateway, which inspects the packets and the information present in the packets or the application layer data that is present in the packet. This doesn't do that. It operates at the session layer, which is layer 5 of the OSI model, and primarily focuses on verifying whether a session is legitimate before allowing traffic to pass through. It is, if you can see the diagram here, it actually establishes two different connections. One is called as an outside connection with the outside host, and the other one is the inside connection with the inside host. How does it work? The gateway establishes two separate TCP connections, and one between the internal user, this is your internal host, and the gateway, and one between the gateway and the external server. Now, once both connections are set up, the gateway relays the packets between them without inspecting the actual payload. This is most important one. This is the primary difference between your ALG and CLG. This does not inspect the actual payload. Instead of filtering based on packet contents, what it does do is it determines whether the connection itself should be allowed or denied based on predefined security policies. That means this is going to allow or deny a connection request, whether this connection can be established or not. But once the connection has been established, it will start allowing the packet. It does not inspect the payload of the packet. The gateway typically masks the internal IP address, enhancing privacy and also security. Now let us see what are the advantages of going for the CLG. First one is efficient performance. Because they don't analyze packet content, they introduce very less latency than application level gateways. That means they do not degrade the network performance and they are quite fast. Next one, as I told you, they can mask the internal IP addresses. So it provides better anonymity. They can hide the internal network details by using NAT or network address translation, preventing external users from directly identifying the internal hosts. Third one is simple to configure. This is pretty much easy to manage than the application level firewalls because they don't require the deep packet inspection. Then what are the disadvantages or limitations? Obviously, this, as I told you, once it becomes simple to configure, because it does not require deep packet inspection, that itself is a limitation. Lack of deep inspection, thereby it cannot detect any malware, exploits, or any other threats that are coming through. Second disadvantage or limitation is it is still susceptible to certain attacks where Trojan horse malware or malicious data, because if the connection is considered as valid, your CLG is going to allow it. It is not going to verify what is the content within the packet. That is one of the limitations of CLG. And CLGs cannot be used as a standalone firewalls. They are generally used often alongside other firewalls because it lacks content filtering and the intrusion detection capabilities. So these are some of the limitations of CLG. Let me give you a quick comparison. These are some of the common use cases of CLGs because they are often found in corporate networks where internal users are trusted and administrators are primarily needed to control outbound connections rather than verifying the internal people. These CLGs are also frequently used in SOCKS proxy servers, which establish secure tunnels for applications like VoIP, instant messaging, and peer-to-peer networks. They are also deployed alongside ALGs to balance security and performance. Now, as I said, I'm going to show you a quick comparison between CLGs and ALGs. CLGs function at layer 5, ALGs or application level gateways function at layer 7. It doesn't do any packet inspection because it only validates the connections. Yes, it does do packet inspection, and that is why it provides you a high security level, whereas a CLG provides only a moderate security level. The performance of CLG is faster because it doesn't take much time, and it also induces a low processing overhead, whereas an application level gateway is slower because it involves a deep packet inspection. Common use cases are SOCKS, proxy, network address translation for the CLG, whereas for the ALG, web filtering and email security. Protection against malware, CLG does not give you the best protection around, whereas an application level gateway, because of its deep packet inspection feature, does provide you a higher protection against malware. So in the next video, I'm going to introduce to you firewall basing, where we will be discussing about bastion host and host based firewall and personal firewalls. Till then, take care and good luck.